Hey guys, Jimmy. Welcome back to our SPI Ultrasound Physics Registry review. Feel free to pause the video after I ask the question, give enough time to answer it before I answer it. Let's dive right back into this thing. Question 27. Click on the artifact. The artifact is right here. This is a range ambiguity artifact. Question 28. Which is not associated with a narrow bandwidth? A. Longer duration. B. Damping. C. Longer pulse. Or D. No images. The answer is B, damping, because a narrow bandwidth doesn't use a backing material or a damping layer. Question 29. Which way will the beam steer based on this pattern? A, to the left, B, to the right, C, straight down, or D, will not steer. The answer is to the right. And how we figure this out is the beam of a transducer will always steer towards the delayed pulse. If you look in this diagram here, this pulse here is the most delayed. So this beam will steer to the right. If you look at this wire here, these pulses here are coming down the wire to activate these active elements. So this one here looks like it's going to activate this element first, then this one, and so on and so forth. This one here will be the last one to activate this element, meaning this is the most delayed element. As a result, the beam will steer towards the most delayed element. So it's going to steer to the right. Question 30. Which is not associated with a wide bandwidth? A, pulse inversion, B, short duration, C, continuous wave Doppler, or D, high axial resolution. The answer is C, continuous wave Doppler, because this will use a narrow bandwidth. Pulse wave Doppler, however, will use a wide bandwidth. Question 31. How do you make the line on the right look like the line on the left? A, map, B, scale, C, baseline, or D, angle? So how do we make this line here look like this line here? And if you see questions like this where they're asking how you make a vessel or a line void of color look like a vessel or a line filled with color, but if there's no map or scale, then always assume they're talking about the scale. So what we have to do is adjust the scale. And to be specific, you have to decrease the scale because the scale is too high over here, making the color go away. And then it was turned down here to make the color fill in. Question 32. How do you fix range ambiguity? A, coded excitation. B, increase PRF. C, decrease PRP. Or D, decrease depth. The answer is A, coded excitation. Now, other ways to fix range ambiguity are if you decrease PRF, or increase PRP, or increase depth. Now, keep in mind, if you decrease PRF, you're actually increasing depth, as well as if you increase PRP, you're increasing depth. PRF and PRP are reciprocals of each other. So again, these would be correct if this said decrease PRF, increase PRP, and increase depth. But here, coded excitation is the best answer. Question 33. What is the circled area evaluating? A, axial resolution, B, lateral resolution, C, contrast resolution, or D, spatial resolution? The answer is C, contrast resolution. Anytime you see circles going from light to dark, or even if they're just all dark, they're evaluating the contrast resolution. Question 34. What type of artifact are the arrowheads pointing to? A, beam width, B, slice thickness, C, range ambiguity, or D, side lobe? The answer is C, range ambiguity. And to help minimize this artifact, you're going to want to increase your PRP, decrease your PRF, and all the while, this will increase your depth. Question 35. How do you improve axial resolution? A, high quality factor, B, narrow bandwidth, C, coded excitation, or D, decreased depth? The answer is C, coded excitation. And remember, depth has nothing to do with axial resolution. So you can increase it or decrease it all you want, and axial resolution will not be affected. Question 36. Which best describes what transducer created the sector? A, curvilinear, B, endocavity, C, linear, or D, annular? A way you can tell the difference between a curvilinear and an endocavity sector is that endocavity sectors will have an extended field of view to the point where this will almost flatten up top here. Question 37. How do you improve temporal resolution? A, more pulses, B, high duty factor, C, short spatial pulse length, or D, thin PZT? These types of questions are pretty tricky, so you have to go through each option very carefully. So let's look at the first one. A thin PZT crystal creates higher frequencies. Does that affect temporal resolution? Not really. Short spatial pulse length? That more so affects axial resolution. More pulses? That actually degrades temporal resolution. High duty factor? Yes, this will improve it because a high duty factor means that you're examining or evaluating superficial areas. Question 38. What type of artifact is the arrow pointing to? A, refraction, B, propagation speed error, C, mirror, or D, side lobe? The answer is A, refraction. Question 39. Which is not associated with a matching layer? A, multiple layers, B, wide bandwidth, C, impedance, or D, 0.25 wavelength thick? The answer is B, wide bandwidth. What a matching layer does is it creates an impedance that is as close to a PZT on one side and the skin of a person on the other side, so that the pulses can be transferred from the PZT crystal to the body more efficiently. If we didn't have a matching layer, then about 80% of pulses would be reflected back to the transducer. Question 40. Drag and drop the letter X on the artifact. So where would you put this X on your image? This image is pretty tricky, but what's happening here is that this right here is mirroring off the bladder. So this is actually the artifact. So you're just going to place your X right here. Question 41. Which is not associated with the non-imaging probe? A, high quality factor, B, continuous wave Doppler, C, narrow bandwidth, or D, short duration? The answer is D, short duration. Non-imaging probes will actually have a long duration. Question 42. Which is not associated with this sector? A, mechanical, B, phased, C, annular, or D, convex? Make sure you read these questions very carefully because this is saying which is not associated with this sector here. And the only one here that's not associated is a convex transducer. All these other ones will create a sector just like this. This is referred to as a triangular, pie, or fan-shaped sector. Question 43. Which will degrade contrast resolution? A, high compression, B, high contrast, C, wide dynamic range, or D, harmonics? And the answer is B, high contrast, because a high contrast means you have a bistable or black and white. Also, you have a low compression, a narrow dynamic range, fewer shades of gray, and of course, a low dynamic range. Question 44. What is the circled area evaluating? A, contrast resolution, B, axial resolution, C, spatial resolution, or D, lateral resolution? So with these types of questions, you always answer with the best possible option. And in here, the best option is contrast resolution. Question 45. Which is associated with a wide bandwidth? A, high quality factor, B, images, C, continuous wave Doppler, or D, long duration? Again, to reiterate, always pay attention to what the question is actually asking, because this is saying which is associated with a wide bandwidth as opposed to saying which is not associated. So make sure you read it carefully and then go through your options here and ask yourself, do any of these match this question? So this is saying which is associated with a wide bandwidth. So we're going to go through each one here. A high quality factor, this is associated with a narrow bandwidth. Continuous wave Doppler, this is associated with the narrow bandwidth because there's no backing layer. Long duration, that's a narrow bandwidth because a short duration is associated with the wide bandwidth. So the fact that we have images means that we have a wide bandwidth. Question 46. Which best describes inertia? A, resistance of blood flow, B, turbulent blood flow, C, pressure of a vessel, or D, Rayleigh blood flow? The answer is A, resistance of blood flow. Question 47. How do you degrade lateral resolution? A, wide bandwidth, B, more pulses, C, thick PZT, or D, higher PRF? The answer is C, thick PZT, because a thicker PZT will use a lower frequency, which will degrade lateral resolution. Question 48. This sector will not affect which of the following at any depth? A, temporal resolution, B, frame rate, C, T-frame, or D, angular resolution? The answer is D, angular resolution. Angular resolution is another word for lateral resolution, and the sector was created by a linear transducer As you can see, the lines are going straight down and they're not diverging. That means angular resolution, aka lateral resolution, will be unaffected in the near field and the far field because the lines are going straight down instead of diverging. So the line density is the same going all the way down. Question 49. Which will occur based on this pattern? A. Beam will steer to the left. B. Beam will steer to the right. C. Short far field length. Or D. Long near field length. The answer is D, long near field length. So when there's a short time delay between the first three signals on each side, then this will create a long near field length as well as a focused unsteered beam. So in this example here, you can see that the signals close to the far left and close to the far right have a longer time delay. And because of that, it's creating a taller arc. Whereas this example, you can see that there's a smaller arc. So think of, if you have a taller arc, you're going to have a shorter near field length. Now, when we look at this first diagram here, you can see that the arc is much smaller and has less time delays, thus making the near field length longer. Question 50. Which is not associated with damping material? A. Short pulse duration. B. Sound absorption. C. Long duration. Or D. Similar impedance to PCT. The answer is C, long duration, because damping material or a backing layer will create a shorter duration. And that concludes all the questions for this test. I'll hurry and write 25 more questions and upload that video as fast as I can. If any of you are looking for mock exams to study for your upcoming SPI boards, feel free to subscribe to our mock exams on our website, ultrasoundboardreview.com. Or if you're looking for more of a one-on-one SPI tutoring, go to our website and subscribe, and I will teach you everything you need to know for your upcoming SPI boards. I also sell an SPI workbook that will help you study as well. I'm Jim with ultrasoundboardreview.com. We'll see you next time.